So far, we assumed that scalability was an indefinite, never-ending phenomenon. Of course it is, from the user's perspective. But from the network designer's perspective, there's a limit to providing scalability with the existing technologies. And that is precisely the point that pushes the engineering and designers community to look for more scalable solutions. So, in this particular module, we are going to explore the constraints on scalability and how these constraints have an effect on the overall scalability that a system can support. We shall understand what are the parts of a model and how these parts have their own limited scalabilities and how these scalabilities grouped together result into the scalability of the overall system. Aristotle said, and with due deference, I quote him with slight deference and objection to his statement, he said that the whole can be greater than the sum of its parts. Of course, at a metaphorical level it can be true, but on more concrete levels, we have seen that the whole cannot be greater than the sum of its parts. Of course, when I say this with apologies to Aristotle. Now, let's recall the parts of model. A computer network that we wish to simulate would comprise of submodels including nodes, the protocols, the devices, the algorithms, and so forth. Each of these has its own respective list of attributes, characteristics, and parameters. For example, a node, either a client computer or a server, could be defined by the computing capability it has, the memory at hand. The protocol could be defined by the operations which they perform, how they perform, and what messages they use. The devices are identified by the number of ports which they support, the voltage ratings, the encoding standards, etc. Let's assume that we are looking at the overall constraint and limit to scalability. For that, we have to use a scientific way. First, we look at their respective bounds. For example, the total number of nodes that could be defined is given by Nmax. The overall operations that could be given by a certain protocol given as Omax. The message formats which could be realized with a given limited data structure is Mmax. The devices each have maximum of Pmax ports, and their specifications have a limit as Smax. Now, we are going to use a min-max decision rule that will tell us the maximum scaled up size of a network. The min-max decision rule says that the minimum of the maximum of all these is actually the maximum scaled up form of a network. It is generally said in English that the strength of a chain is actually determined by the weakest link it has. As a specific example to the physical constraints which these networks would have, let's take the example of addressing. IPv4, a celebrated addressing scheme with 32 bits allocated for addressing, actually got exhausted in 2011. And the last known stoppage or the closure of the IP addresses is known that happened just in 2015. IP version 6 so far enjoys the title of being the unconstrained IP addressing. with 128 bits of addressing at hand. Now let's assume that everything in the world starts to get an IP address to communicate over the internet. This is also known as the Internet of Things. 2 to the power 128 would then be the overall constraint limiting it. So the maximum network size that the whole world could see with IP version 6 is 2 to the power of 128.